Hello guys, welcome to my class, and this is class number 8 on the topic of integration. And in this class I will cover a subtopic of integration of trigonometric identities by substitution. I'm Engineer Goodluck, and you can contact me through my email goodluck.dawudk@gmail.com, and I'm from Tanzania. In order to use integration by substitution, the function f dash of x and the integral must hold the following properties. 1. F dash of x must have two functions such that g dash of x is a first derivative of g of x. So in this case, we let g of x is equal to any variable. Or the function f dash of x must have two functions such that g dash of x over g of x, such that g dash of x is a first derivative of x, and in this case we let g of x is equal to any variable. Okay, consider the following examples. 1. Integrate tan of x dx, and 2. Integrate cot of x dx. Okay, consider example number 1. When we integrate tan of x, we replace tan of x with integral of sine of x over cos of x. This is from trigonometrical ideas. Okay, when we have this function, when we look, cos of x is equal to g of x, and sine of x is equal to g dash of x. So I let u or any variable is equal to g of x, which is equal to cos of x. So let u is equal to cos of x. When I differentiate du dx, I get negative sine of x. So when I substitute back integral of sine x dx is equal to du negative, and the cos of x is equal to u over u. So integral of du over u is ln of u. So we have negative ln of u plus constant. So what is u? Is cos of x. So we have negative ln of cos of x plus constant. Okay, try this. Integral of cot of x dx. It is the same for the previous example. Okay, let me continue. Consider the following functions. If I have the function like this, sine of theta raised to n times cos of theta raised to m d theta. When I integrate this kind of functioning, I must consider the following case. In this case, either sine theta or cos theta can be either g of x or g dash of x, depending on the value of n or m. So we have this function. So if n or m are odd and m is greater than n, just we are shown. In this case, we let cos theta is equal to g of x. We let cos theta is equal to g of x. If both n and m are even, we substitute cosine of double angle identities in these expressions. So we use, where there is a sine, we use this identity 1 minus cos 2 theta over 2, and where there is a cos square of theta, we use this identity cos 2 theta minus 1 over 2. Okay, if m is odd and n is even, then we let the value under n, which is sin theta, equal to g of x, is equal to g of x. To understand this principle, let's look some examples. For example, integrate cos theta sin raised to 3 theta d theta. In this case, we have 1 and 3. This is 1 and this is 3. Since 3 is greater than 1, then we let u is equal to sine of theta. 1 or 3 are all odd, and since 3 is greater than 1, so sine of theta is under 3, so we let sine theta is equal to g of x is equal to u. So when we differentiate the u with respect to the theta, we get cos theta d theta. So cos theta d theta is equal to du. So we have integral of sin theta is equal to u. So we have u raised to 3 times du, which is equal to u raised to 4 over 4 plus over 4 plus constant. But what is u? U is sine of theta. So when you substitute, you get sine of theta raised to 4 over 4 plus constant. Okay, let's look on another example. Integrate cos of theta square times sine of theta d theta. Okay, in this case we have 2 and 1. Since 2 is even, we let u is equal to cos of theta, because the cos of theta is under 2. So when we differentiate the u with respect to theta, we get negative sine of theta d theta. We let u is equal to cos theta because u is in front, is under power of 2, and sin theta is under power of 1. So we let even is equal to g of x, which is equal to u. Okay, when we substitute sin theta d theta is equal to du. So sin theta d theta is equal to du is equal to negative du. This one, sin theta d theta is equal to negative du. So in this case, cos theta is equal to u. So we have integral of u square du negative. So we have negative u power 3 over 3 plus constant. So what is u? Negative cos of theta Okay, let's consider the following example. We have to integrate the function which is the cos square of theta sin theta d theta. Okay, since 2, which is this one, is even, and 1, which is this one, is odd, then we let cos of theta is equal to any variable, since cos of theta is under even power of 2. So we let u is equal to cos of theta, simply because it's under even power. Therefore, when we differentiate u with respect to theta, we get du is equal to negative sine of theta d theta. So we have seen sine of theta d theta is equal to du times negative. So when we want to have sine of theta d theta like this one, so we must divide by negative both sides. If we divide by negative, here we'll get negative du, and here we'll get positive sine theta d theta. So sine theta d theta, which is like this one, sine theta d theta is equal to negative du. Where there is sine theta d theta, we put negative du, and whereas there is cos of theta, we put u. So here we have u square is equal to integral of u square, and this one is negative du times du negative. Okay, is equal to negative u raised to 3 over 3 plus constant. But what is u? U is cos of theta. When you substitute by cos of theta, we have cos of theta raised to 3 divided by 3 plus constant. Okay, let's see another example. Cos square of theta sin square of theta d theta. Okay, since both cos of theta and the sine of theta are under power of 2, then we substitute cosine of double angle. Cos theta is under power of 2 and sin theta is under power of 2. So we use double angle identity of cosine. So sine square of theta is equal to 1 minus cos of 2 theta divided by 2, and cos square of theta is equal to cos 2 theta minus 1 divided by 2. So when I substitute, where there is cos square of theta, I put this one, cos 2 theta minus 1 over 2, and where there is sin square of theta, I put this one, 1 minus cos 2 theta over 2. So I have the following integral. I get negative out of the integral sign because I want to have cos of 2 theta minus 1. So when I get a negative out, and the 2 is 4. So I have negative 1 over 4. This negative is this one. When I get it out, here I have cos of 2 theta minus 1. Cos of 2 theta minus 1. This is for this. And for this one, which is cos of 2 theta minus 1 over 2, 2 and 2 is already 4. So here I have cos 2 theta minus 1. Like identity like this one, cos 2 theta minus 1, and this is cos 2 theta minus 1. So it is a square, the theta. So when I expand this one, negative 1 over 4, I get it out of integral because it is a constant. So I remain with cos square of 2 theta minus 2 cos 2 theta plus 1, like this one. Cos square of 2 theta minus 2 cos 2 theta plus 1 d theta. So what is important? We must know what is double angle for cos square of 2 theta. We must substitute another double angle for cos square 2 theta. Like for cos square of theta is this one. So what is for cos square of 2 theta? In this expression, we must remain with power 1, not power 2 or higher power. So we must replace this one, cos square of 2 theta, with its equivalent double angle identity. So we have the following. Cos square of 2 theta is equal to cos of 4 theta minus 1. This is over 2, this is over 2. So when I substitute back, I have negative 1 over 4 out of integral bracket, where there is cos square of 2 theta, I have cos 4 theta over 2, cos 4 theta over 2, minus a half, minus 2 cos 2 theta, plus 1 d theta. So when I multiply by negative 1 over 4 integral and d theta at the same time to this expression inside the bracket, I have the following. Here I have negative 1 over 8 cos 4 theta d theta, cos 4 theta d theta, and here this is negative a half and 1 I get positive a half. When positive a half I multiply by negative 1 over 4, I get negative 1 over 80 integral for d theta, minus 2 and 1 over 4, I get negative plus. So 1 over 4 times 2 is a half integral of cos 2 theta d theta. So here when I integrate, I get negative 1 over 80 integral of cos 4 theta is equal to sin 4 theta divided by 4. In differentiation, we multiply by 4. So in integration, we divide by 4. So we have sin 4 theta over 4. And in this, we have theta over 8 plus a half times, in this we have sin 2 theta over 2 plus constant. So when I multiply this to this, I get sin 4 theta over negative sin 4 theta over 32 minus theta over 80 plus 1 over 4 times sin 2 theta over 4 plus constant. Okay, thank you. See you in the next class.